Okay, thank you. Yeah, so my name is okay. So my name is David. Like Pau mentioned, we were working with event sourcing for the past 10 months in production. So I want to give a brief explanation or introduction to no to the concepts related to this. So okay, let me see. Wait, okay, okay, okay. So, okay, so first, I will give a brief what's event sourcing, right? So basically, event sourcing is an immutable log of change that is that is an old concept. In this case, this change we call events, and it's bringing this idea of an immutable log of change to the application level. So this is used in a lot of different places, and event sourcing is about bringing the idea to application level to store the data of our application and to persist the data of our application in a different way. Uh, uh, this is, but like I mentioned, this is a really old idea. This is not new. The immutable log of change it has been used for a long time, long before computing even. Um, for example, in accounting, this is for at least 300 years. When you are doing accounting, you're doing a ledger or you're doing an accounting book. You always accountants always write new events or change to the accounting book, but it doesn't. The concept of deleting or updating something in an accounting book it doesn't exist. You always add new stuff. So if there is a mistake, for example, what they do is they add a new event or a new they add a new event to what to fix the mistake that was done previously. But deleting, updating this concept it doesn't exist. It can be illegal even in some places to delete stuff from accounting books. You always have to add new stuff to delete to update or fix mistakes. Uh, and most businesses have been doing this for years. Banks, insurance company, we're talking about 200, 300 years where we know that they have been working in this way. Um, and the point is that they always store the facts that that are happening in the system or that are happening in the system. They don't really this business they don't work with the concept of current state of the system. You only work with concept of events that have been happening. The current state is calculated at any time with any algorithm depending on what you need. For in general, an accounting book you have credit and debit. So the algorithm is subtracting and adding the credit and debit to get the current state. In this case, the current balance of an account, for example. Uh, and yeah, and this is how these companies work even today. The For example, the balance in your account, if you have a bank account, the balance, uh, your balance is not a column in a relational database. This is not a sort of true of your balance. If, for example, you are in an ATM and you make a mistake, there's an error in the ATM, and you get subtracted money, but you don't get the cash. When you call the bank, they will not check a relational database to see your balance. This is not the source of truth because there can be mistakes there. What they will check is the events that are associated to your account, and they will check the events associated to the ATM. And based on these events, they will do maybe an automatic algorithm, maybe manually check it. But this is the source of the true of your balance, the events that are happening, and based on this, they will calculate your real balance in case of mistakes. Mm, and Git is another example of this. Uh, Git is an immutable log of change. In this case, each change is this change. Instead of events, they are called commits. But a commit is really used only contains the change that have been happening in the change that happened at that point in your file system or in your project. You only store the lines change or the characters change, but it doesn't store a whole file. It doesn't store folders. A commit doesn't have any of this. And actually, Git never stores for a snapshot of your project. if you go to github.com and you go to your project, you select a branch, what you are seeing there is a projection of all the commits, and this project is generated and is displayed to you. And Git does the same in your file system. When you do a checkout on your console, what Git is doing is it takes all the commits and it generates the projection in your file system. But this projection is never stored in Git. Git only works with with a log of commits, and this is the only thing that you are downloading from the server. The only thing that Git is really cares about is it's about the events that are going on in your project. Well, this concept is really useful, having this immutable log of events, because you can first, it allows you to recreate the state of your system at any time that you want to recreate it. You can do it with Git. You can do a checkout to any particular commit, and you will get the history up until that point. And this allows to have great traceability. Like in the ATM example, if you have all the events going on in the ATM, you can find errors or mistakes that have happening, and it helps a lot with auditing your system. You can see if there is a problem. If you were only updating a row or a column in relational database, you don't really know the values that were there before. So, but if with event, you're always appending something, so you will always have what happened before in the system. Uh, and from the business part, you don't really, it's really hard. You cannot predict where will your business be in 1 year, right? It's really hard to know what your boss will ask for you in a year, statistics or anything they need to know. You don't know when you are developing a new project, and your business will change. So the best you can do is really store everything, keep track of everything that's going on in your system, all the events that are going on, keep track of that. Yeah, you will be more prepared for what you are asked for in the future. Uh, and this is very related to the domain-driven design concepts. Domain-driven design what it suggests is to bring the business and the technological side together. Is the main proposition of domain-driven design. And the idea is that domain experts, they don't really care about routers or databases. They don't care about the network. They only care about business workflows, and they only care about business processes and the workflow related to these processes. And building, defining from the technical point of view, defining these workflows as events is more close to what the business actually is trying to do. One technique for doing this is event storming. So with event storming, basically, what you do is you put together the development team with the domain experts directly. You set up a meeting or multiple meetings, and you try to guide the domain experts to build the system for you. So you ask them to build your system of commands that are entering the system and events that the system are producing. And what you're doing with this is that the business people is really defining the architecture of the system for you. This way, when you do the actual coding, what you are doing is really close to what the business people is thinking, and it will be a lot easier this way to later, if you have a problem or you want to evolve the system, to interact with the domain experts. It will not be hard as when you're trying to translate from a relational database and you're trying to get them to understand what's going on there. It's really hard. But if you model it as events and they are doing the modeling with you with this technique, then the system is really close to it. And then the events that they are the domain events that they are defining is simply most of them will be the events that you will store in our event sourcing system. So yeah, it really helps to keep the business and the technology together, and to make them understand it better. Uh, like, yeah, this is an example of, well, a seven storming is really messy, but the good thing is that the domain experts are speaking a language that the technology is understanding, and the technology side the same. They are speaking a language together with the domain experts. A lot easier to develop a business. So, well, I'm going to now I'm going to show a little bit how we work with event sourcing in a more technical way, the more technical part. The idea in this case, this is a little example we created. We have a meetup system, and we have a string of events, right? Um, we have, in this case, let's say we have a created event. These events are ordered in time. So we have a created event which contains the data for the meetup, the name, an ID, a number of spots available. We have a spots changed event with will change it change the number of spots. So instead of add update, you are just appending an event to change the spots from the original creation. And RSVP accepted and RSVP canceled with the ID users that are coming to the meetup or the ones that are canceling their invitation. So, well, what we're going to do is we need what we need. This event is what you are actually storing in your database, is what you are persisting, but at some point you need to know the current state of your application. So this current state we call it an aggregate. Uh, is well, it's really related to functional programming because what you're basically doing is you're doing a left fold of every one of the a left fold of all the events. You can call a reducer too. For example, if you have worked with React and Redux, it's doing the same thing. Instead of events, you have actions. The reducer is and the reducers are calculating the current state of your application. It's the same principle. Uh, in this case, it's an aggregate. We're doing a left fold or reduce. What we're doing is the algorithm step on each event and takes the data that it needs and updates the current state. This is done in memory. No, this is done when you need the aggregate is when this is calculated. It's not, but the state is not stored in the database. You only store the string of events. Um, so yeah, when we have the created event, we sort the data. Then a spot changes, simply change the number of spots in your aggregate. Then RSP accepted simply adds the user to an array you have with the people that will go. And if you have a cancel, you simply delete the ID user from the array. So yeah, it's pretty simple. The important part is that this is the source of truth, and this is where your data really belongs. This is just something you calculate when you need to read the data. In our case, most of the time we calculate the aggregates in memory. So you do an API call, get data for meetup, and this is calculated. There are techniques or libraries where you can store the state in projections, or if you are in a distributed system, you're using something like Kafka with the events, and then you are projecting this to SQL database, for example. You are storing the state in that case, but the source of truth is always the events, not not the aggregate. The aggregate is always just a cache that you have just to read data. Okay. Well, one important part here is that what happens, for example, is you have an accepted event, but the RSP is already full, right? So this creates an inconsistency in your system. If you have 5 accepted events, no canceled, and you have only 4 spots, then you have stored an inconsistent string of events. You have an event that doesn't make sense with the system. And the way to solve this is not on the reading but on the writing. You should not write events that can create an inconsistent state. So at the moment you are writing the event, you have to check if this event is correct or it makes sense to store it at that point. For this, well, we use a writing aggregate. The way we use it is that our aggregate, what it does is that it receives a command. It tries to apply the command. It checks if it can apply this command, and if it can do it, then the aggregate generates the event related to it. So now, If the command is correct, you can apply. Now you go to the past tense. You mean okay, accept RSV, and then you go to accept it because once you have the event, it means that you accepted it, that everything was correct. And how this works is pretty simple. First, we receive the command from a controller, from a console application, CLI, doesn't matter. You receive the command, and the aggregate, what it does, well, first it goes to the database, get the string of event for the ID that the command has. This gives us all the events stored related to this meetup, and it generates the current state. So what is what we saw before, basically. The current state in this case, let's say that we have the ID 1 meetup with 4 spots, and we have already 2 users registered. And this simply generates, in this case, it checks is everything correct, right? The meetup is open, so it has a space left, so it generates a new event. And then we store the event in string. Then we store the event in the database. We append the event to our string. One useful part about this is that you have the impure part of your application in the entry point and in the exit, and all the calculation in the middle is only pure functionality. So it's really easy to unit test this because you can just mock a string of event, put it inside with real events, and use not test the safe, at least in your unit testing. Um, well, but what happens, for example, if we try to apply the command, but we cannot we cannot apply this command, or we cannot accept this RSVP because the spot is already full, right? So the aggregate, what it does is, well, it simply returns an error, right? Then the caller decides what to do. You return an error to your API or to your interface, whatever. So yeah, but okay, now in the database size, what database we can use for this? How do we store this? Like I mentioned before, a lot of big system use distribution system for this, and they have like something like Kafka, where Kafka basically allows you to store. It works like a log store. It's really fast for writing, and you just write logs, and it persists your data. And then you can have processes reading these events and projecting it to a Cassandra or to a SQL, whatever. This is the more complex way to do it. But there are also other ways to do it. There is a database called Event Store. Also, it's a database built for this, built for event sourcing. You can create strings in this database. You can store events there. You can create projections inside this database. So as soon as you add a new event to a string, the projection is updated automatically. And it also works as a messaging system. So you can have these 2 transactions together. Instead, usually you store something in a database and then go to Rabbit. So the transaction gets more complicated because you interact with 2 systems. With Event Store, you have this is easier. In our case, we didn't use Event Store. We use Postgres for this. We use a library called Marten. It's a micro ORM library for .NET. It's a .NET standard library, 2.0, I think, and it's based on Postgres. This library it only works with Postgres. It doesn't work with SQL or another. It has a direct dependency to Postgres, mostly because the author says that Postgres support for JSON is a lot better than the other systems. They are more advanced in that. So right now it is built for this. The library is really easy to use, really easy to set up, and it has minimal external dependencies. I think it only has a dependency on Newtonsoft, but well, like everyone else. Um, well, let's see how it works, right? Well, this is the way to set up the library. It's really easy. It just needs a connection string. It needs, well, I don't know if I mentioned, it works, Martin works both as an event store and a document database. So it's a library that allows you to use Postgres to take advantage of the JSON of the JSON support for Postgres. It allows you to use it as a document database, or in our case, we use it as an event store. and yeah, you set a schema for the event store, a schema for the document store. You can use the same schema like we did, and you can tell him to automatically generate the migration for your database. So you tell them how to create all, and it creates as soon as it runs. If the database doesn't have the tables that it needs, it will automatically create them. And this is what it creates. It creates 4 tables, I think. This is the main one that we care about. Is it creates a table for your events. It has a data structure, which is a JSON, which is the actual data of your event, and a bunch of metadata. The string ID is really important because it's what is the ID that logically keeps events together. For example, for a meetup, the meetup ID is the string ID. So you know that all the events related to this ID belong together to a workflow. Yeah, I have another metadata. It have the version column is really nice because it helps you work with concurrency if you have concurrency issues in your system. The .NET type for the serialization of the data type. And this is a presentation of the data. Um, like I say, basically, this is what's important, no, the most important for you, the actual data, and all the metadata related. You can use it. Timestamps sometimes are really important too. Well, for example, for this an accepted event, you have the method ID and the member ID. In this case, the method ID is the same as the string ID, like I mentioned. So it's what logically group together the events related to a meetup. Well, and uh, this is a helper class that we create for the writing aggregate. So basically, when you have your writing aggregate, you need to know the current state, no, of the meetup. And this is simply an enumeration with the different states. Here I show, for example, this have an empty state and a published state. And what we do with the helper class is that we define what events we allow to store depending on the state that you are. For example, if you are in the empty state, we allow the opened event, but nothing else. If you are published, then you can cancel the event. You can cancel the meetup. Sorry, you can close the RSVP, accept RSVP, but you don't allow, for example, the opened event because it's already open, so it's inconsistent. And if it's in the empty state, we don't allow RSVP accept because you only allow this in the published state. It's just a simple function that will check if you can. It will tell us the state if it can raise a particular event. And well, this is okay. So and this is the code for the first part we saw when we were doing the aggregate, to calculate the current state. This is the code for this. So we receive a list of events, no? It's the string of events that we receive. We use link queue helpers to do the aggregate. And for each event, what this will do is take the list, go to each event, and for each event, it will apply the reduce function. The reduce function will check what event is reading at that time. So you are going to the first event. If a created event, then we change the state of the aggregate, which is the enumeration we used before, and change the number of spots. If it's an RSVP accepted, we add the member ID to the RSVP array or list, and if it's a decliner, we remove it from this list. So what this is doing in the end is this is like the actual state, no, of the of the system, and what we're doing in the reduce is updating the state. We use the aggregate function to go to each event, and it's updating the state of your system. And then this is the bottom part of the same class. This is the writing part. What we have is an accept RSVP function that receives the command, and simply after calculating the state, we check if we can apply the command. First, we check the number of spots. For example, if the list of RSVP if it have more people than you can actually fit, then we return an error. We cannot apply this command because we are in a state that is not allowed to use. And we use a generic function that will check if it can raise this event. this check raise, what it does is go to the state and see if we are in a state that we can allow RSVP, new RSVP. If we are in a published meetup, we allow it. So yeah, we return true. But maybe we are in a different, maybe we're in a closed state or an empty state, so we cannot raise this event. So we return an error to our system with a message. Uh, and this is our application service. This is what I showed before. This is all pure functionality. We are not interacting with any library, with Martin or anything. This is all is receiving a list of objects, which are the events. Now we need to interact with the database, and this is where we use Martin. Uh, in this case, what we do is we inject the document store. This is the Martin class, and we open a session. So it's just we open the transaction there, and Martin, what it does is it have events, it have the events subclass. Well, it goes to the events, fetch all the events associated to the meetup ID because this is the string ID. So just give me all the events associated to this meetup. And we use Martin support to select direct Martin link queue support to select the data column. This is what we showed before. In the database, we have this data which contains the actual data of the event, and we can use link queue to select this data directly and give me a list of all the events, only the data. Maybe you could select, maybe you need the timestamp for some other functionality or whatever, but in this case, since we only need the actual data, we select directly and well, do to list, get the list of events. Now and later, we create our aggregate with the method. This is gives me the current state. So sorry, this is the create function. Just we took the event for the database, so now we pass it to the function, so we get the current state of the application. And now we call the accept RSVP command. Uh, so this will tell us in a result if we can apply this command or if we cannot apply this command. Uh, there's something missing here. Okay, something I didn't explain. What we do in the writing aggregate is that every time we apply a command, we have a list of pending events. Basically, we have the aggregate. It will add events to these pending events if it can apply them. So when we try to raise the event, if it's fine, we add it to this list. So we know later that these are the events that we are not stored yet in the database. Sorry. This is what we do basically. Yeah, we fetch the list, we fetch the events to the database. We use our aggregate to see if we can apply the command, and then we store the pending events in the database using Martin. These are the two functions with Martin. Well, we finish the transaction, and we return the results. So yeah, well, this is it. It's a really interesting subject. It has helped. I think it has been really nice to work with this type of application because I actually got the point where my boss will ask me for data that we didn't thought about storing it before. But we had it here, so all we have to do is create new aggregates, but the events are already there. So you can do all kinds of statistics and traceability, and it's really easy to follow the workflow in your system when you are storing the workflow uh, the workflow results or the result of your workflow in your database, because it is what's happening in the system. You're storing it completely. It's really good. It's really good for debugging and to tracing what's going on in your business. Well, I put some reference here. I think we will upload the presentation later. Just some videos from Greg Young and Martin Clement on event sourcing and working with data. And well, that's it. If you have any questions, yes. Sorry, the aggregate, the implementation. It, it, well, there is a book I didn't put here. Uh, It's a book about microservices. They explain about you're asking about the writing aggregate, no? The yeah, but basically have been well with Empower Me. We have been getting into the subject and a lot of reading. There's not a con. It's very new, no? So there's a lot of theory and on the videos and everything, but the implementation in this case is very similar to a book called I forgot the microservice. There's some microservices book where he talks at some point about events and aggregates and how to store it. I didn't put that reference here, but yeah, there's not a best practice yet, yeah, about this. It's just a lot of theory. In general, it's very related to functional programming, so you can take a look at that. Yeah. Mm. Yeah, well, on the maintenance part, the good thing about this, like I say, is that you really split the impure part of your application, the storing for the pure, so it's really easy to test. Uh, Now, about the inconsistent, well, there is a problem. There was a problem we faced that our business leaders they like to go to the database in production and do queries there, and here you can do it, but it's not so easy because you have to query over the JSON. Uh, you have to this is a let's say that this is a uh, event sourcing is really good for writing, but then you have to do the reading. So you have to do tooling. You probably will in the end will have to build some tooling for your support so they can read the data in a easier way. Uh, Now, you should, if you see inconsistent, you should never update the events because you are losing everything. What you can do is append new events. Well, depends on the problem. Yeah. Well, because it's really good when you have a workflow. So, for example, if you only have, we have our business is a workflow. So we validate data, no? We receive some data from a client and we have to validate with images and everything. So we have different processes doing these validations. So it's a workflow that in the end returns something. If you have a workflow like this, usually this is the core domain of your application, the main workflow. You are using Amazon, so you have a cart. The core domain for them is probably adding items and removing items and going to a checkout. And this is a workflow. This is really good for workflows. Probably for your sidebars, maybe you have a operators or a customer support mini site. Probably for that you can use a relational database for the login, authentication. This is not your core, but for the core workflow of your application is really good. So yeah, you can apply a lot of projects. Hmm. There actually the risk is always less in this than in a regular relational database because you are always storing everything. Maybe it will be harder to read, but you have to go case by case. You have to think that, like I said, this is not new. This is really old, and even database engine inside, they work with this. You have a transaction log, and when you build your current state of the database, the database engine is just reading the transaction log, and this is the inside the database is an event is is an event store, or is working with an immutable log of events. And Git is the same, so it's not really new, and it's really safe. A lot of people didn't use it before because you need a lot of storage space. So yeah, you the use case where you will not use it is that you generate so many events that you run out of this space. But in the present, this is usually not an issue. The data you're storing is probably worth more money than the what you're paying to store that data. But yeah, it's case by case. Mm. Yeah. Yeah. You in the when the project grows bigger. For our case, yeah, we didn't need it. We don't need it. But this big application, they are doing that. The source of truth is the events, but yeah, they are pre-calculating projections. The get event store database, it does that internally. You store the event and you put with JavaScript inside. You can tell him to generate projection every time you write a new event. The projection is automatically updated. Uh, but yeah, it can get more complex. No, it's a database engine. The get event string, the get event store is a database engine. They store it, they do it themselves. With Martin, you can generate projections too. You can create algorithms that when you write the event, Martin automatically in the transaction, it store a document with the current projection. So you can do it with Martin too. We did do it in some parts. Well, in our case, sí. Mm. Yeah. Well, this was a greenfield project, so we never start with a relational model. Like we didn't build a relational model at all. What we started is asking the domain experts about the workflow, and we started writing the events that were happening, and it was a distributed system, so it was just the events were basically what was going on in the distributed system. So we set a command. This command sends command to different processes, and we return events. These events is basically what we were storing. So the hardest part is to not think about tables. Basically, when you do this, is try to think about the workflow and not about okay, because we are used to that. We're used to they tell me something about the business and you think about tables. It's just don't think about tables. Think about events and commands. And the splitting, well, yeah, it's case by case, but yeah, basically the main workflow is seven store. The relational database use basically right now we use it mostly for authentication for our private users. But in general, you can store everything in a event store. Well, the the main point, yeah, and the best you can do is to think about the writing first. You have a business, okay, I need to write this, and this, and in the future you will think what projections you need, but you already have the data. So yeah, there's no time, so yeah, later we have pizza and beer and
Yeah, this is a really hard topic. So yeah, even the also about main practices, and there are no main practices, I would say, but all the systems they can be modeled differently, and event sourcing is really nice if you go in the domain-driven design path, but it's really complex, and it only pays off if you have complex domain. If you have a crude system, don't create please user updated event, user login, whatever, right? So basically it's for a stream of events, and now that they are really valuable for the business, right? Because I don't know, retailers that you are people clicking in websites, zooming, all these events, they go through workflows, and the trading systems in the stock market, this is the more aggressive, but then the asynchronous workflows, if you have async workflow, like the one that you go to the hospital or to the security, whatever, you have a paper, right? And you put a you go somewhere else. This, all the workflows are asynchronous if you think about them, and event sourcing, it's actually, you have all the history, all the record of the process, and this is really, really nice. Instead of having, actually, if you think about the databases, what you do is you create the table, an audit table, for storing the audit of the things that have happened before, and then you are messing up there. So, but okay, that's another topic. Bye.